In this video, I'll be doing some harder polynomial questions. So the question goes a bit like this. So I have a polynomial as follows: x cubed minus 3x squared minus 2x plus 4. And they tell you that the roots of this particular polynomial is alpha, beta, gamma. So 3 at most, right? Because it's a cubic. It's asking you to find a polynomial with the roots alpha squared, beta squared, and gamma squared as part 1. In part 2, using this fact, using the newfound polynomial, I had to find the sum of alpha squared, beta squared, and gamma squared. And in third question, I had to find L cubed, beta cubed, and gamma cubed, the sum of them. Okay, let's get started. So to do the first part, I'm going to say p of x, my polynomial, is equal to what I have just up there, minus 3x squared minus 2x plus 4. And we know that if I substitute in alpha, this is equal to 0. Alpha cubed minus 3 alpha squared minus 2 alpha plus 4 is equal to 0. Okay, now the trick to this is really thinking of this as p of root x. Okay, so basically it's the opposite of alpha squared. If I had alpha cubed over there, I would have done x to the power of a third. So instead of x to the power of a half, I'm doing a third. So you'll see soon enough why I'm doing this. So now I will have x to the power of 3 on 2 minus 3x, right? So squared times a half is 1, minus 2x to the half plus 4. And I'm going to say this is equal to 0, and then so actually I'll do that in the next step. The reason that I did this is because now if I substitute in alpha squared into this thing, if I substitute into x equals alpha squared, I end up coming back to here, right? P of alpha, right? So the polynomial that's generated by this is the one that has roots alpha squared, beta squared, gamma squared. Because if I substitute x equals beta squared, I will end up getting P of beta, which is also equal to 0. So the trick is essentially, if they ask you for alpha to the power of 4, beta to the power of 4, gamma to the power of 4, you'd be substituting in x to the power of a quarter. Okay, so I hope the logic is pretty straightforward. Okay, but by the definition of polynomial, I can't have these non-integer values as my polynomial. So what I'm going to do is I'm going to set this equal to 0 and then make it a polynomial. Okay, so let's do that. Okay, so I'm going to leave these two elements on the left hand side, and I'm going to take the other two, the one that's already integer numbers in terms of the powers. I'm going to take those two to the other side. Okay, so we'll end up with x to the 3 on 2 minus 2x to the half is equal to 3x minus 4. Okay, now this side, on this side, I'm going to take x to the half outside, right? So, and then I will end up with x, well, that's going to be x minus 2, right? Because this x to the 2 on 2, add them up, you end up getting 3 on 2. But anyway, so there you go. So that's equal to 3x, 3x minus 4. Now the trick here to make it into integer powers is that I'm going to square both sides, because when I square both sides, I will end up with x minus 2 all squared is equal to 3x minus 4 all squared. And therefore, and from here, I will end up getting, so I suppose I should expand it out, because unfortunately I need to use that in part 2. Okay, so I'm going to expand it out right now. So I will end up getting x cubed. So I'm jumping steps over here because I'm assuming that you know the expansion of this thing, which is x squared minus 4x plus 4. Okay, I'm not going to do the same for the next one, but basically I will end up with minus 4x squared plus 4x on this side, and then when I expand this out, I will end up with 9x squared minus 12 times 2, that's 24. 24x plus 16 on this side. Okay, so bringing everything over to one side, I will end up with x cubed minus 13x squared, and then the rest is equal to 0. Okay, so I don't particularly care about the rest. for part 2. Well, like, you'll need to write it down for yourself if this was an exam question, but I'll leave that up to you. But the reason that I don't care is to find the sum of the roots, which are alpha squared, beta squared, and gamma squared. The sum of the roots is simply the second number. So part 2, alpha squared plus beta squared plus gamma squared, is just equal to 13. Okay, let's look at part 3. So part 3 is asking me to find alpha cubed plus beta cubed plus gamma cubed. Okay, so in order to do this, I can go back here and try and do my step of finding the polynomial of x to a third, and then doing this process all over again of doing exactly what I did for part 1 and 2. But this time I'm actually not going to do that. Okay, the reason is this power over here, alpha cubed, is actually the highest power over here. So if they match, if the highest powers of the polynomial and the highest power of the root match, you're going to stop and think for a bit, because it's a bit of a hint. Now over here, I said that as soon as substitute in alpha, I get alpha cubed minus the rest of it is equal to 0. Okay, so using that intuition, I can say that alpha cubed is equal to, actually, I'll rewrite this as x cubed. X cubed is equal to 3x squared plus 2x minus 4 for alpha. Oops. So for alpha, beta, and gamma. Okay, so this only satisfied for alpha, beta, and gamma, for nothing else, because that's one of the roots, right? Therefore, the sum of alpha cubed plus beta cubed plus gamma cubed is equal to 3 times the sum of alpha squared plus beta squared plus gamma squared plus 2 times alpha plus beta plus gamma, I guess minus 4 times 3. Okay, because I need to use this 3 times. Okay, so alpha plus beta squared plus gamma squared I found in part 2. Alpha, beta, gamma, now the sum of those 3 roots, we can use the original polynomial, and that's equal to 3. Okay, because that's the sum of the roots. This thing over here is the sum of the roots. Alpha plus beta plus gamma. Okay, and there you have it. So it's going to be 3 times 13 plus 2 times 3 minus 12. Okay, so that is the final answer. So I hope that was fairly straightforward. If you do have trouble or any questions or comments, let me know. But thanks for watching.